Welcome back. My name is Marcus. We are going to be doing experiment number three, or lab number three, which is conservation of momentum. I do have to read all this. So the experiment we're going to demonstrate is transfer momentum, for instance, from one marble to multiple marbles. Um, it's part of Newton's cradle system, where it goes a little like pendulum thing where it goes down, hits the marbles, and moves them around. So we're going to recreate that just on the table, and I'm going to be using up to 5 marbles, 2 rulers, and a custom ramp that I built, excuse me, which I have labeled in centimeters. That'll tell me uh, which number I am starting off for my speed, because my flicking is going to be different. So this will help me kind of keep some of those numbers together in order. Um, all right, let me set it up and then I will come back. All right, so the way I have it set up here is I'm using my salt, which is roughly 6 centimeters tall. Let me write that down. 6 centimeters height. Okay. And the way it works is I'm going to line this up. And trial number one is one marble growing at 4 stationary marbles, which are going to be touching. I'm going to pick my speed. So I'm going to do like 2 different trials here. I'll probably do one at like 10, one at 20, maxes out at 25. So it's going to gain enough momentum going down the ramp, hopefully follow the path, hit these marbles, and then momentum is going to push X amount of marbles out. So let's give it a shot. So trial number one, if I can do this, is going to be done at 10. There we go, 1 marble. Let's try it again. Make sure they're all touching. Now we're going to put a little bit more speed to it. We're going to go to 20. Still 1. Okay. Let's try to max it out. 25. And almost 2. 1, and then whatever you want to count that as. All right. Part 2, collision data of moving marbles. I changed it up a little bit. I'm going to use these as my height, which is 2 centimeters tall. So let's say 2 centimeters tall, starting at 10 centimeters on each side. That way they have the same speed, the same everything, just different marbles, starting from my right side and my left side. So the experiment is going to be 1 versus 1, 2 versus 1, 3 versus 1, 4 versus 1, 2 on 2, 3 on 2. So let's begin. One, two. Wow, they totally missed each other. A lot harder than I thought. Try again. Okay, try again. I'm gonna have to edit this video. 1, 2, 3. 1 and 1. So 1 on 1, they bounce back. 2 on 1. 1, 2, 3. 1 went left and 2 went right. All right. Next one. 3 versus 1. 1, 2, 3. One left and 3 right. Interesting. Last one is 4 versus 1. 1, 2, 3, go. Ooh, none went left. 4 went right. Interesting. All right, now we're doing a 2 versus 2, 2v2. 1, 2, 3. That went everywhere. So 2 and 2, basically. Last one, 3 versus 2. 1, 2, 3. Switched one. All right, got all my data. All right, last one. 4 marbles versus 1. We already know what's probably going to happen. And of course, they all went out. So 4 versus 1 at 15 starting equals 5 marbles out. All right, 3 marbles, 2 in play. I'm up. 1, 2, 3, go. All 5 came out. So we started at 15 and 5 marbles went out. All right, same concept. I'm going to do a couple, but I'm just going to start 15. But now we're going to do 2 marbles. It took 2 out. 1 stopped on the line, and the other one just kind of flew out. So 2 marbles took 2 out. All right, time to recap. Basically, my notes is a little scribbly, so I apologize. But we used 2 rulers. We made a runway. I actually used a ramp, which I set up about 6 centimeters tall. Released my marbles from one end, while the 4, 1, 2, 3, or 4 were in the middle, to see what happens from the stationary point of view. It's in my notes. Basically, 1 marble went down. There's 4 marbles in the middle, and momentum traveled all the way through. Only 1 marble went out. Then it was 2 versus 3. 2 of them went out. 3 versus 2, all 5 of them went out. And then for the last one, which is 4 versus 1, all 5 went out. For the collision version, I basically changed it up to try to keep everything the same. I went 2 centimeters up, released them about 10 centimeters up the ramp, so that way it was more of a controlled environment. Basically a 1v1, they went down, they collided, and bounced back out. 2 on the right side, 1 on the left, they went down, and 2 left on the right. Basically, they just transferred energy. 1 left, so forth and so forth. The only one that was off was the 4 versus 1. Actually, it wasn't off, correction. 4 on the left, 1 on the right. As they went down, they collided. The momentum was stronger on the 4 side, so that means none of them went out on the left side, because that's where the 4 came in at, and the 1 came out on the right. 2v2, basically like the 1v1, they both came in, they collided, and they both went back out. The 3 on the left and the 2 on the right, as they came in and they hit, 1 just transferred over, so now we have 3 on this side and 2 on this side, and they went back out. That's pretty much the consensus of the lab. And again, just to improve the consistency of it, I used an actual homemade ramp, measured it out, and launched them from the same point so they have the same speed. And that's that. So I appreciate it. See you in lab 4.